hello. Right, okay. Right. Let's set it like this. Right, okay. Then we can sort of see live here. Okay. Right, hello. Right, okay. Hello, Katie. I think I will soon start the lesson. Right, but this one today is a for year 13 NCEA Level 3 calculus. Hopefully becomes a good valuable lesson. Yeah. Okay. Let me see. I just need to check the YouTube channel as well. Right. And then I will make it a little bit lighter here. The YouTube one is a bit dark, eh? Why this is so dark? YouTube one. Anyway, yeah. This one's dark as well. Hello, Katie. Hello. Hello, Jamie. Jamie, this one is a really high level one. But yeah, you may enjoy it. Yeah, I'm doing streaming for the level 3 student today. Yeah, dydx for log. How to dydx for log. Yeah, that sort of stuff we're gonna do. This calculus stuff. I hope this one goes all right. Yeah. Okay. So I will wait for what is your YouTube. YouTube is the same mathematics sensei. If you type in, you can actually. Right. I will probably. I probably can drop the link here. Hopefully. Right. Adjustment. Oh yeah. This is a YouTube. Yeah. Then yeah. Hello. Oh, there are lots of comments this time. Last time I couldn't figure out how to turn the comment on. But hello. I don't know who you are, but yeah, I just say hello. Yeah. Yeah. So that I will take about probably 3 more minutes and then start talking about differential equation, which as we say differential, but there's actually integration. Okay, here's a bug. Yes, I got rid of it. Right, yeah. That was, I'm wondering whether YouTube one. The YouTube one is working? あ、こんばんは。Hello. Yeah, as YouTube one is working as well. Okay. Alright, soon I'm going to, yeah. Hello. Wait, right. Yeah, I just go and get water, and then we can start talking about differential equation. Okay. Right, so that I want to wait a little bit longer so that I want to make sure everyone's here. Yeah, in the meantime, I just want to introduce this one. I bought this one in the Westgate foodie. This is called dorayaki. It's a really popular sweet in Japan. Well, this one was really nice. So I will repeat it. I just wanted to introduce. This one was about $6 or something. Yeah. But anyway, if you are, you are interested, or you are going to Westgate, the foodie, and the Japanese section or something, and you no, it's a foodie as it's close to the freezer section. I think I found this one in front of the freezer section. Anyway, right, okay, yeah, right. So then I will start the lesson for today. Today's lesson is level 3 calculus, working for level 3 calculus external. Hopefully, so for the YouTube, I wonder whether the sound is alright or not. Yeah, okay. But anyway, so that I will start talking about talking about the question here. Okay, so the differential question, a differential equation, as one of the merit and excellence skills that you always see in the exam. Okay, then this one, if you master this skill, you can definitely get one of the merit or excellence question correct. Okay, so that I really want you to master this type of question and skill. And then after this, we are using differential equation to create to deal with. I can't fit this one in screen now, but anyway, this one as a word question, supposed to be merit or excellence question. Usually excellence question, but yeah, then I will show you what we are going over this kind of question here. Okay, right. So that first, what I want to do. Thank you for the gift. Yeah. I will have to. I just need to move this one a little bit this way. Yeah. Okay. So when you see the ordinary, okay, so I just go over or talk about ordinary integration. So when you see integration like this, we usually have the one kind of, let's say 3 or something, then one kind of variable with the variable, isn't it? So that we need to have the same variable inside of the integration, the same one as dx, okay? If we are doing dx, we need to have the expression which is in terms of x here, right? So this one is, we always do this one first, isn't it? If you add 1 on top of 3, x to the power of 4, and then divide by this number, 4, and then plus c, wasn't it? Okay? And then what about this one? Let's say y, 2y plus 3 to the power of, like that, dy. This one is the same. This one, y to the power of 2, and then 2 divided by 2 is 1, so you cancel it out, and 3y, and then plus c. Okay? Then we're going to use this one a lot later, so I just want to revise this one. For example, y 1 over z dz. This one, as you are using, if this one is 1 over, for example, x to the power of 2 dx, you are converting this one into x to the power of negative 2 dx. And then you add 1 on top of it, next to the x to the power of negative 1. And then you divide this number by this number, which is negative, and then plus c, wasn't it? Okay? But if this one is 1 over z, there is no powers form here. In this case, do you remember what you use? Come on, are you doing too? Please tell me. I'm not. Anyway, yeah. Oh, this helpful. Kumon. Yeah, Kumon as a Japanese learning system, and then as a last part of Kumon was actually integration. I think that's a quite a popular Japanese curriculum, and then I know some of the teachers teaching Kumon. And then the Kumon is actually one Japanese teacher's name, math teacher's name. But anyway, right, okay, yes, ln. We are using ln for this one. ln, and then z plus c, okay? We usually put absolute value here because we will not allow negative number to fit inside of log, so that we put absolute value here, okay? So this is a basic the revision, okay? Then we are looking at this one. Differential equation, as we are doing integration here. However, what's this? Auto accept request. What kind of request is it? What is request? Oh, sorry. I'm not used to the live streaming today. Yeah, anyway. Yeah, this one. So we want to integrate this one, but we've got dy dx here, and then dx x squared and y here. So that, as I mentioned before, we want to have x and dx, or y and dy. At this moment, this one is, we've got the mixed up here and the mixed up here. So we need to tidy up so that we can have only x and dx here, only y and dy here, right? And then if you manage to sort it out, you can integrate on both sides at the same time, okay? Which means, how can you shift this one to this way, and this one to this one to this way, and x squared to this way? You are dividing by x squared on both sides to shift x squared to this way, and then timesing dy on both sides to shift dy on this way. So as long as you have x and dx, and then y and dy, that's all. Haven't studied any of external. Yeah, I the only one who has. Right, so if you haven't learned for external, this is a right thing, right live stream to visit, because this is if you manage to get this one correct, and you're quite likely to pass the exam, because this is one of the merit or excellence question. So this calculation is merit level, but the following one is excellence level, okay? So yeah, so this one, you just, okay, sorry, okay. And what did I want to do? As this one, if you divide by this one by x squared on both sides, times by 1 over x squared, and you can get rid of x squared on this side, isn't it? And if you times by dy on both sides, and you can get rid of this dy here. What I want to say is if you the next step is gonna be 1 over x squared dx equal y dy. Okay? Then if you form this y, all you have to do is you put the integration sign on both sides. Then you integrate this one. Remember this one was, we've already done this one, right? Just before. So I'm not going to explain this one as negative x to the power of negative 1 plus c, negative x to the power of negative 1. Then this one as y squared over 2. Then plus c, okay? You don't have to add, create plus c on both sides, because this one is a constant, isn't it? So that means if you have, for example, c1 here, c2 here, that means if you do c2 take away c1, it's gonna be some value, isn't it? So, which means exactly the same as plus some value here, okay? So you don't need to put, it's not terribly wrong, but this is good enough, okay? So let's see this one. Yeah, NCEA Level 3, yeah. So shall I give you a time so that you can solve these other questions? What do you reckon? Or do you want me to start? Yeah, talk about it, or yeah, I probably start doing it for the first one, so that if you see two of those, you probably can get hung of it, isn't it? So we want to have y on dy on this y and dy one side, and then another side is x. In this case, you just do divide. I want to shift this one and this one somewhere. Okay, I mean, the dx is here, so I want to have the expression in terms of x here, which means I need to move this one this way. In this case, you need to divide by x plus 1 on both sides, which means times by 1 over x plus 1 times by 1 over x plus 1. So I can cancel this part, okay? Then I move this one this way, so that times by dy, times by dy, and then dy is cancelled out. So the next step is 1 over x plus 1 dx equal 1 over y squared dy. Okay? Then this one and this one, we can put the integration on at the same time. This one is the same as this one, isn't it? Okay? And then this one is the same as you're using log here. Okay? While I continue, yeah, until then, yeah. So this one is gonna be, this part is log x plus 1. Then the right side is, equal. Right side is the same as this one, so negative x to the power of negative 1, and then plus c. This is gonna be the answer, okay? Right, so can you, I wasn't here for the first one. Okay, right, okay, don't worry, let's keep moving, Right, so I will share these 4 questions so that if you can do this stuff, I will give you time a little bit so that you can start working on it. So I just give you time, okay, about 2 minutes, and then I will come back. Okay, I go and get the chocolate. This stuff in school, but glad I never go level 3. I've never needed math that much. Okay. Yeah. Yo, can you do one more? Okay, shall I do one more? Yeah, I'm happy to do it. Yeah, Ali T. I never use that math equation in my job. Yeah. Caucasus. Yeah. So Ali, if you don't use math in your life, you may probably use it in the future. Hey, well, I don't know. But as a math is for you to enjoy, more like we are learning math because it's fun and beautiful. We are not learning math because you just want to use it. Okay. All right. Yeah. Okay. So shall I? Yeah. I will start talking about this one. Right. Okay. So the next one is this one, isn't it? Okay, I will shift this one. This one. Okay. So I will move dy this way, and then x e to the power of x this way. So that means you need to times dy on both sides to move dy here. Okay, and then you divide dy x to the power of x, e to the power of x on both sides. So that means what you have to do is 1 over ex dx equal y dy. Okay, then you can integrate this one directly, but for me, my brain is easier if I for my brain, it's easier if I change this form into e to the power of negative x form, right? Then if you put integration sign on both sides, then what's going to happen is if you integrate e to the power of negative x, what is that? This is going to be negative e negative to the power of negative x, isn't it? That's the left side. And then right side is y to the power of 2 over 2. And then plus c. Okay, this is the third one. Okay. What about fourth one? Oh, sorry, I forgot to put plus c. Oh, good. Yeah. Right. Okay. Next one. This one is you times by dy on both sides. Right. Okay. Dy on both sides, and then dx divided by times by dy, and then divided by cosine x. So 1 over cosine x dx equal 1 over y dy. Okay. In this case, how do you know what is a cosine x? I mean 1 over cosine x. 1 over cosine x is this one, isn't it? Okay. So if you integrate this one in this one, right side is easy, isn't it? 1 over x, then log y, right? Left one. Do you check the yeah did I formula sheet? I've got somewhere. I forgot. I thought I was preparing for that. I just want to formula sheet NCEA Level 3 calculus. Right, I just want to so that I would like you to remember which page has got the integration and differentiation stuff. And if you open the formula booklet, the first page on your right, you've got the differentiation and the integration information. Okay, and if you look at this one, and you can see wait just a moment. Wait just a moment. Cosine x is not gonna be it's not gonna be easy one, isn't it? This one is, I think this one is gonna be a really complicated one, because I mistyped. I think this one was a swap around. I will change this one into dx dy equal y over cosine x. Okay, that's gonna be complicated, so that I will skip this one. And then if you do this, you can do this times this equal this times this, cross multiply, becomes like that. And then integrate this one. Sorry, this one I mistyped. I typed it in by myself, and then I made it, typing it in here. Top and bottom it's not. Yeah. Okay. So anyway, this one is y squared, and then this one is sine x plus c, isn't it? Okay. Yeah. Okay. Right. This one is. This is the right side, and this is gonna be the left side, and this is gonna be the right side. So this one, I move this one here, and then you divide by this one here, 1 over x plus 1 dx equal 1 minus 1, y minus 1 dy. Okay? Then if you integrate this one, as I mentioned, this one is a log. X plus 1 equal, and then this one is y squared minus y plus c. If I'm doing too quick, just let me know. Okay. Right. Okay, next. The last one is I move this one here, and then I move this one here. Okay. So that so 5x to the power 4 1 dx equal 1 over 2y dy. So far so good. And then you put integration sign here. Then if you integrate this kind of stuff, it's easier for you to think of put the coefficient in front, and then change this one into -4 instead of 1 over x to the power 4. And then this one is totally up to you, but I personally prefer this way of setup. Can you explain the different definition of the integral? Cracker, sorry. If I try to explain the definition of integral, it takes too long, and then I will run out of the time to explain all of the stuff. So that brackets or absolute value. If you are putting the using a log, we put absolute value here, like this. But if you are not using absolute value, you're not using like log like this, you put just a bracket, okay? Right. Thank you for the gift. Yeah. Right. So this one, if you do, you are focusing on this one. If you integrate this one, you get -3, wasn't it? And then you do this number divided by this number, so -1 over 15. Okay. Equal. This one is a log, isn't it? So half log absolute value y plus c. Okay, integration. Yeah. Right. I'm trying to follow the read the comment. It goes down. Yeah, that's a comment. I just want to check the comment, and then thank you for the gift. And right. Okay. Anyway. I'm going down. Thank you. Yeah. So that I explained I'm a math teacher at one college. I'm actually head of department, and I'm teaching level 3 calculus. And then I taught what the definition of integration in differentiation and that sort of stuff. I really enjoyed teaching them because they are so lovely, and then they are keen to learn. So that I took time to explain the things, so that if you are in my classroom, and then I could talk about it with you. But today, as we are focusing on what we can do during the live stream, and yeah, on top of that, my computer is not good enough to do live streaming, so that's why I'm using my phone. So if I can use computer, it's easier for me to show how it works. But unfortunately, I can't do that right now. Okay, so what we are doing is we are using this differentiation, general solution of differential equation, this way of thinking, into this word question or everyday word. Thank you for the gift. Yeah. Wow. Thank you. Yeah. These kind of stuff. And the first one is economic growth. So that concept is actually used in our everyday life. Economic growth, population growth, and radioactive decay, and then Newton's law of cooling. So these are the application for integration here. Okay. Yeah. Thank you. Thank you for the gift. Yeah. Anyway. Yeah. So this one is example. This is a structure. So you are not. These information are not given in your formula sheet. So unfortunately, you need to remember this one. However, this one is not. If you are practicing these kind of question over and over, you don't really need to remember it. You can actually can say that by heart. Okay. I just want to check what's going on with the message here. All right. Okay. Nothing. Okay. Sorry. Okay. Then, right. So you can't really read because this one, isn't it? It's quite a lot. Further, should I don't know. Should I? Sorry that I'm not playing the game or something like that. I just want to teach math so that today. So when I'm doing the live streaming for the other time, I may be able to do battles and that sort of stuff, but not this time. Okay, right. So that biologist observes that bacteria colony is growing continuously at the rate of 15% per hour. And then I will show you how it works first, and then you guys can do this one and this one. But if I do like this, can you read whole sentence? I just leave this one. But yeah, what's a bacteria? Yeah. Okay. All right. This one. So okay. So for this question, the initial investment or initial value is really important, and then rate, and then time, and we are starting from this type. Okay, this one as it's not economic growth. So let's say population growth here probably because it's about bacteria. Okay, so we are using this one. Okay, dp over dt. That means you are differentiate the value of p in terms of by time, isn't it? And then this one is a rate. Okay. In this case, then P, right, I just need a white paper here, blank paper here. So I just want to explain about this one. So dP dt is Rp. So R is a some number, okay, rate of some number, okay? Then P is a some variable, okay? Then if you convert this one into some form, you are, sorry, I'm a little bit Thursday. I'm tired. I went down to the city today and then come back. So anyway, right. So we are using the differential equation here. So we move this one this way, move this one this way. Okay. What I want to do is 1 over p dp equal r dt. Then you can integrate this one. Okay. Then if you do this, the left side is log p, isn't it? Then right side as you are integrate this value by t. So this is simply rt plus c. So far so good. And then this one, as the key point of this question is from here to here. I'm sure most of you guys can understand up to here, isn't it? But from here to here, as Thank you. Thanks. Thank you. Right. Oh, I just. How do I? Sorry, I set a new goal. Yep. Thank you. Right. Okay, sorry about that. Yep, okay. Anyway, so from here to here is a little bit difficult, so I just talk about this one. This one is logarithm, as for example, log, so when x equals bigger than 0. If you see this one, ln means log e x y, okay? And then if you go back to level 2, log a b c means a to the power of c equal b, wasn't it? Okay? So a to the power of c equal b. So if you follow this structure, this one is e to the power of y equal x, isn't it? So we are doing the same thing. Integration of RLT. Yes, integration. So R is just a constant, some number. So basically that is from here to here, dt, and then, for example, this one, basically the same. If you integrate this one as 3t, isn't it? And then if you integrate this one as RT, this is not variable. It's not changeable. Okay? Good. Right. So that, in this case, this one is e to the power of this one is this one, isn't it? Okay. So that means p. Let's say p is population so that p is bigger than 0. So we can ignore the absolute value. Okay. So p equal e to the power of RT plus c. Okay, which means this part, I just rewrite this one like this. 2 to the power of 3 plus 2 means 2 to the power of 3 times by 2 to the power of 2, isn't it? I just did the same thing for here. Okay? In this case, e to the power, yeah. So then if we recognize c as a sum number, this one is a constant, isn't it? Okay? Then we are recognized, when we are using this one, we recognize this one as an initial value. So initial value, let's say p0. Okay? So p and p0, e to the power of RT. This one is a basic way of thinking or dealing with this question, okay? Okay, so if you look at this information, the rate of growth is 15 per hour, okay? So then initially 1,200 bacteria, which is P0. Okay, I will use red pen for this one. So that is that here? Yeah. P0. Okay, P0, and then let's say growth as K. Yeah. Yeah. Okay. So let's say this one is P0, and then 15% is, let's say, R rate of that stuff. Then R equals 0.15, and then we are trying to figure out the answer for this one. can you yeah. And how long will it take to population to double, becomes double? And then bacteria growth can be moderated by this one. Oh, right. So I usually use R for the rate, but this one it says K. So let's say put K here. And then let's solve this one. So, right. Then if you solve this kind of question over and over, you don't really need to take these steps over and over. But because this is a first question, I will show each step here. So that means dp dt as k equal 15, so that 0.15 and then p. Okay, then we are solving differential equation here. Then we put integration sign here, and then this one is log p equal 0.15 t, and then plus c, and then p equal e to the power of 0.15 t plus c, and then this part you can say p0 e to the power of 0.15 t equal p. Okay, which means this part was how many? 1200. P equal 1200 e to the power of 0.15 t. Okay, this is a formula for this bacteria. Okay, and then the question is the population. How long does it take? Will it take to double? It becomes double. The bacterial growth can be moderate. Yeah. Okay, so that which means double of this one, isn't it? Which is 2,400. So 2,400 equal 1200 e to the power of 0.15 t. If you solve this equation for t, that's the answer. Okay, that's the time, isn't it? Okay, so that right, I don't have space, so I will copy this one down here. Like that. Okay, then obviously you can cancel this one. 2 equal e 0.15 t. How can you figure out answer for this one? You take log on both sides, isn't it? Log 2 equal log e to the power of 0.15 t. Is that okay? Yeah, so you put this one in front, and then log to the log e means 1, isn't it? Because e to the power of what gives you e? 1. So log 2 equals 0.15 t. Okay, which means t equal 0.15 over log 2. So the time is log 2 over 0.15, which is t equal 4.62. Okay, and then what is the time for the time frame? Is this one hours? Okay, so it says hours, so this is hours. Okay, this is a one, yeah, the way you solve these kind of questions. Okay, right. Okay, let's see the next question. Is that okay? I will show this one in this way so that you can read all of the question there. Hi. Say hi, golden boy. Hello. Yeah. Okay. A new car is purchased for $65,000, and depreciation continuously at 12% per year. And then when will the car be worth half of its original purchase? Right, so depreciation. Right, that's yeah. So what we need to figure out the initial cost, which is this one, isn't it? So this one is P0, okay? And then this one is rate. I use K for the last question, but I use R this time, okay? And then we are solving the question in using this one. So dp dt as so the rp. Okay, this one is something you have to remember, but the form is always same. Okay, then this one is p 1 over p dp equal r dt. It's exactly the same you have to do. Yeah, and then this one is 12% depreciation means negative 12%, which is R is negative 0.12 dt, okay? This is a bit tricky part, isn't it? And then you put integration sign here, and then log p equal negative 0.12 t plus c, and then you are converting p as e to the power negative 0.12 t, and then you don't have to write this part over and over. You can say that just times by p0, which is, how much was that? Right, 6,500. So p is, hello Jamie, hi, e to the power of negative 0.12 t times by 6, 5, like that. Okay. I might have made a mistake. I shared the wrong link to my level 3 calculus student, I think. Oh, it's too late, isn't it? But anyway. Okay, so this one, p equal e to the power of this one equal this one. Then what was the question? So we want to figure out the time that we have the price becomes half price. So you can do divided by 2 here to put here, but I can't be bothered doing that because you end up canceling 65,000 in the end, right? So what you have to do is, this is a half price, right? And then this is a first price, and then this is a depreciation. Then what you need to figure out is a value of t. So that means if you want to solve for t, you need to cancel this one, isn't it? Okay, if you cancel this one, half is e to the power of negative 0.12 t. Okay, and then if you put log half equal log e to the power of negative 0.12 t, that means this one cancelled, so then negative 0.12 t equal log half, which means t is negative 0.12, log half over negative 0.12. Then you type it in the calculator. So log half, and then over negative 0.12. Yeah, then which is like 5.776, so that let's say 5.78, and then you check that unit, which is per year, isn't it? So that is year. Okay, right, years. Okay, next. Is that okay? Is there any questions so far? If there is any question, I just stop and then answer your question. But what's your best tip for excellence question? Jonathan, I will talk about it in the next question, not this one. Okay. And then I will show the excellence question for the complex number and algebra today after this. And then I can give you a tip as well. There is a clear pattern even for excellence question. There's always only several concepts you can examiner can give you, so that there is a clear tip there. Okay. Is there any question? I just check that your comment. Right, okay. Let's do it. Okay. So that last question is this one. The an investment interest at the rate is this one in this one. And continuously, how long does it take to, right? So the initial cost is $5,000. And then this one is a growing rate, so that means R, which is 0.065. Okay, so let's say dp dt is 0.065p. Then I move this one here and then this one here. So 1 over p dp equals 0.065 dt. Okay, so that you put integration here, and then I will skip the process. By now you can understand this one now. P0 e to the power of 0.0565 t. Okay, I just skip the process because you can actually skip here. Yeah, separate the variables. Yes, that's it. And then this one, P is 5,000. And then P0 is 5,000. And then we want to know when 12,000 is going to be. So 12,000, I put 12,000 instead of P, and then 5,000 instead of P0. And then e to the power of 0.065 t. Okay, then I just canceled this one. Okay, and then I canceled this one because I want to figure out the value of t. Okay, and then I take log of both sides, and I don't even put log on this side. I just put this one directly like that. Okay, then t equal 0.065 and then log 12 over 5. And then you probably realize now I don't need to put absolute value here because this is obviously positive value. Anyway, so annum means year, isn't it? How long does it take means the answer form must be something years, okay? And then typed in the calculator. Log 12 over 5, and then over 0.065. This one's 13.4, right, let's say 7 years. Okay. Oh, try again. Okay. Yeah. All right. Okay. Right. So the next question is gonna be the real excellence question from the past here. Okay, shows that result needs to. Yeah. Okay. So this one, can you read this one? Right. I will put this one on side like this, so you can see. I've got the answer on the bottom, so I can't really show. Right. I will show this one like this. Yep. Okay. If you can read this one for now, that would be great. Right. I wonder how many people visit this chat and then live streaming and then got scared and then run away. Eh? Yeah, I just go and get my water, and yeah, if you can do some step by yourself, that would be great. I just go and then yeah. Come back. Okay, let's do it. Right. Okay. Right, so the oil is used deep fried chips, blah blah blah, and then the oil are left cool to cool, so that it can be returned to a plastic bottle. Ooh, yuck! Hot. We don't want to put the hot oil in a plastic bottle, right? So it needs to be cooled down properly. Anyway, the temperature of the oil is this much, okay? And then 15 minutes later, after the elements is turned off, okay, yeah. And then the temperature is this, and 45 minutes after elements is turned off. Is this one? Yeah, elements turned on. Yeah, okay, yeah. And then oil can only return the plastic container for straight 40, of course. I feel like 40 degrees is still too hot for it, but anyway, yeah, 40 degrees. Yeah, okay. How long does it? Yeah, and then this one is Newton's. Sorry, this one is a Newton's law, which is where's the paper that I did this one. So what I did for these three questions as we use this structure, then there is a Newton's law of cooling. This one. Okay, we are using this one. For this question, you've got this formula. But last year we had this question, and then they didn't give us this formula. So you need to remember this formula. But you don't. If you solve this kind of question, there's about 3 or 4 questions, and you don't really need to remember because your brain will automatically remember. Okay. So I will show you how to deal with this one. Okay. So, okay, just stop the music. It's bothering me a little bit. Yeah. Okay. Okay. So this one is 15 minutes later, 283 degrees. 45 minutes later, 167. Okay. And then we want to figure out when the oil becomes 40 degrees. and you've got that room temperature 22 degrees. Okay, this one is room temperature is super important for this one. Okay, there is room temperature is TA, and then K is basically the same as like the rates that we did just before. Okay, so that what we need to do is you just fit this value in there, but before, which is better, which is easier for you to understand? Yeah, right. So we just fit 22 here. Okay, okay. dt, dt. The capital T as a temperature and then lowercase t as a time, okay? So if you differentiate by time, this one becomes K bracket T minus 22. Is that okay? Then we want to integrate using differential equation. So you are dividing this value on both sides and then times by this one on here. So the next step is K dt, and then this one is 1 over t minus 22 dt. Okay, so far so good. And then are you able to integrate this one? This one is log t minus 22 equal kt plus c. This time we are using ordinary plus c for now, but you can do the same process. Obviously t minus 22, this one is a super high temperature, isn't it? Sleeping perhaps maybe helps. Yeah, anyway, yeah. You need to have lots of sleep just before the exam, okay? Anyway, so that means t minus 22 is e to the power of kt plus c, isn't it? Okay. Then you just change this part into, this one is not initial cost or anything like that. So that this means kt times by e to the power of c. This one is some value, so we usually put a instead of e to the power of c, because it's some constant here. Okay, so I just changed this part into a and the e to the power of kt. Okay, then all we have to do is trying to figure out the value of a and k, because these two are the constants, and then t and t is a variable. Okay, then to figure out this one, there are two clues, isn't it? One is 15 minutes to 183 degrees. Another one is 45 minutes, 167 degrees. Okay, so that means, let's say I put a line here. Okay, inside here. Okay, so when t equal and t equal, let's say, and the time is 15, and then the temperature is 283, and then time is 45, temperature is 167, like that. Makes sense? And then you are fitting this one here, this one here. Yeah, okay. All right, okay, let's do that. So 283 take away 22 equal a e to the power of 15k. Okay, and then this one is 167 take away 22 equal a to the power of e 45t. Okay, not k, then what I'm doing, 45k. Okay, Right. Then simultaneous equation. But before that, we need to sort out the left one. So 22, so it's 6-1. Sorry that I can't do any battles and that sort of stuff. I'm here to teach math. So sorry about that. And then AE15K. And then this one is 145 equal AE45K. Right. Then how you do simultaneous equation is a little bit hard here. It's not easy at all. But I just tell you, we are canceling A first and then canceling part of this one by doing this one. This divided by this as 145 over 261. And then this divided by this. We did this divided by this. So we need to do this divided by this. So AE45K, AE15K. Yeah, okay. Right, so in this case, you just cancel this one, isn't it? Okay, so you manage to cancel one of the variables so that if you solve for K, you can find the value of K, isn't it? Then I just want you to remember the rule. So if you do a to the power 5 over a to the power 3, this one is cancelled, so a to the power 2, isn't it? Which means this one is e to the power 45k take away 15k because you are taking a y. Okay? Which means I did a math method exam this week. Oh yeah, cool. Right, this take away this is 30k. So e to the power of 30k is 145 over 261. Okay? All right. So that in this case, yeah, if you take log on both sides, you can cancel this part, isn't it? Okay? 30k is log 145 over 261. So the k is, this is a long shot. Okay, this one is not finished there. We need to figure out the value of k here in this way. And then we need to figure out the value of a. And then we need to figure out the value of T when the temperature is 40. Okay, that's a long shot. Right, I need another paper. So this is an excellence level, obviously. So if you can understand and then do it, you can find, you can get excellence for this one, okay? So K, and then we need to figure out A. How can we figure out A as we fit this value on here? One of those. Okay. Shall we figure out the value of K here? Right. Okay. Thank you, Netted. I don't know. Thank you for the gift. Right. Okay. Log 145 over 261, then over 30. This one is negative 0.0195 and 6, let's say, like this. 3 significant figure. Okay. Yeah. Thank you. The gift. Thank you very much. What do I have to do? The next. So we managed to figure out K. And then we need to figure out A. So if you do this one, let's use this space. So e to the power 15 yeah, let's say e to the power 15. If you divide by e to the power 15k over 261, and then you can find answer, isn't it? So that e to the power 15, let's say if I times by 15 on both sides, 15k as times by 15 times by 15, so I can write like this, Okay, so if you plug this value in here, that's going to be the answer. So a equal, you can fit this one in there, but I want to have the exact value. I'm not really comfortable with putting the rounded number in there, 145 over 261 over 2, and then 261. But even if you want to use exact value all the time, I would recommend you to put this one like this in the middle, so that if you are making a silly mistake, you still got a score for it. Okay, so that 261 over e to the power of log, man, it's complicated, 145 on 261, but this is always complicated. Okay, this one is 350.1, let's say 7. This is a degree. Okay, right. Then after that, what we have to find is we managed to figure out the value of a and the value of k. So we need to figure out value of t when the degree is 40. So, okay, let's say 40 take away 22 equal, a was, let's say a was 350.17. So 315.17, and then e to the power of, this is a here negative 0.0196, and then t. And if you solve for t, that's the answer. Okay, so 40 take away 22 is 18 equals 350.07 e minus 0.0196. I don't want to take too long because I don't want to hold you guys, so I will use the rounded number, not exact number, but yeah, today. Okay, so I just divide by e negative 0.01696t equal this divided by just 18 over 350. Yeah, like that. Okay, and then you take log on both sides. Then negative 0.0196t equal log 18 over 350.17. So that t is negative 0.0196t. What is t? Oh, no. T. Then log 18 over 350.17. Okay. This is how you do it, and then you calculate. You typed in the calculator and then find the answer. Yeah, well, that's a long shot, isn't it? So, I wonder how many people are watching this one. I've got another question of this one, but because it's a really long shot, I'm not too sure you guys want me to solve this question. This one is from last year. So if you guys want me to explain how to solve this one, I'm happy to do it. But I'm wondering whether I should go with this one or not. I think it's already 1 hour, isn't it? Yeah, I can show complex number and then level 3 algebra stuff with you. Which one is better? Yeah, I wonder. Ooh. Right. I think I will skip this. This question is too long, and then obviously the number of people who are joining this live chat is decreased. But yeah. Anyway, so I will skip the question, and I may create some video later. I think. Do you have a YouTube? I have it on YouTube as well. That if you typed in mathematics sensei, I'm sure the same logo will show up, so that you can check. Yeah, yes, I'm actually doing the live streaming on both TikTok and YouTube at the same time. But if you can follow both, that would be great. Anyway, all right. So that I just want to solve this one. Okay. Find the value of x and y, given that x and y are the real. And this one, okay? We're trying to figure out the value of x and y. Okay, there is a key point that you need to think of. Okay, I just get rid of the papers. I use lots of paper. Papers. Okay. Right, what do I have to do? Right, so shall I give you time to solve this one? Or do you want me to explain this one straight away? So that at the moment, 10 people are joining this. Yeah, live, but right. So that shall I start talking about this one? Right. Okay. So that so find the value of x and y when x and y are real. Okay. If this one is not going to be real, that's going to be a huge problem. But this is real. That's good. But anyway, so what you have to do is you are changing the form so that you can make like this kind of form. For example, if you do x plus y iy equal 5 plus 2i, this means that real part should be exactly the same. So x is 5. And then the imaginary part must be the same. So y equal 2. Okay? This is a goal for us. Okay, this is an excellent question, but I don't think this is super hard one, as long as you remember this one. Okay, so you isolate the real part on left, real part on right, and then real part of imaginary part, and then you just compare and then find the answer. Okay, this is how you do it. And then I will show you this one. Okay. Then if you look at this one, as I mentioned, I want to have x and y on left side and only numbers on right side. So that means I just copy this one here. 1 over x plus iy equal, I move this one here. So 1 minus 2i plus 1 over 1 plus I. Okay. Then if you add them together, and then you compare left and right, and you can find that x and y. But this one as a problem as we've got this value in the denominator, isn't it? So this one is a little bit tricky. But for example, if you a equal b equal so 3 over 5. If you see this one, this should be true as well. If this is true, this should be true as well. So that your goal is you trying to put this one, fit this one in one set of fraction, and then you flip over in the end. Okay? So that because if you flip this one over, this means x plus yi, isn't it? So as long as you can put this one in a one fraction, that's almost done. Okay, this is how you try to do it. Okay, let's do it. So we focus on the left hand side. Okay, how do we do it? We need to have the same denominator to add this one and this one, isn't it? So left hand side, I want to have 1 plus I over 1. Shall we do it? No. I think we want to rationalize denominator here so that we can easily add them together. Right. So rationalize denominator as, do you remember? 1, you are timesing congruent of this one. No, congruent. Congruent? No, congruent is not the word. What was it? What was the word? I forgot. But anyway, anyway. So yeah, okay. So if you times this one, and then you can cancel this I, right? So the left hand side is 1 minus 2i, and then this one is 1 plus I, 1 minus I as 1 squared minus I squared. I squared as a negative 1. So negative 1 plus times negative is positive 1. So that means this part is going to be 2. So denominator is going to be 2. And the numerator is going to be 1 take away I, isn't it? Okay. So if you want to add them together, you need to have the same denominator here. So that means you double this one so that you can have the same denominator as this one. Okay? Right, just a moment. It's got done. Yeah, anyway. Yeah. And then if you add them together, 1 plus 2 is 3, and then negative 5i, which means the real part is 3 over 2, and then imaginary part is negative 5 over 2. So the answer for this one, no, what we got to, sorry, this one is this one, wasn't it? X plus IY. So we need to flip this one over, which means X plus IY equal 2 over 3 minus 5i. Oh, so this one, you still need to rationalize the denominator, isn't it? Am I doing correct? Yeah. So that means this one, you times by 3 plus 5i on both sides. Then this times this is 9, plus this times this is 25 over 2 times 3 is 6 plus 10i, which is 9 plus 25 is 34 over 6 plus 34 and then 10i. So if you simplify it, this is going to be this. So x equals 3 over 17 and y equals 5 over 17. This is the answer. Okay, so the way you do it is not super hard. Yeah, however, you need to do some trick here, and then you need to swap around and then just make a real part and then imaginary part, and that sort of stuff is quite hard, isn't it? Right. Okay, let's say, yeah, I have YouTube. Yeah, I have YouTube, and if you are searching on the same mathematics Sensei, and you can find me on YouTube as well. Yeah. Yeah. Right. Okay. So, yeah. Anyway, so shall we go to the next question here? Okay. So the next question is this one. Absolute value of z is 1. And then z is not 1, which means the real part is not 1. Proof this one is purely imaginary. Okay. So purely imaginary means there is no real part. Okay. Let's see this one. Then the easiest way of doing it is usually we write z equal x plus iy. If you write like this, and you can actually figure out the answer easily for level 3 calculus. If you go to uni, you need to take the different way, lots of different ways. But for now, yeah, let's do this one. So if you are changing x and y, and you can think of this one in the x and y plane, so that is easier for you to understand as well. Right, so if x plus iy as a z, sorry, I just, yeah, absolute value z as x squared plus y squared and then square root. Absolute value means the distance from the origin. Okay, I just want to explain about that. So if this is z, yeah, and then if you want to find that, so absolute value is this distance, okay? Which means if real part is x and the imaginary part is y, that distance is, if you use Pythagoras, x squared plus y squared and then square root is this part, isn't it? Okay, so the z absolute value of z is a square root x squared plus y squared. Okay, so this one is actually size 1, which means if you square, it's still 1, isn't it? Okay, right, next. This one is, yeah, you can think of this one as a unit circle, but quite a few schools don't teach unit circle, so I stopped talking about it. And then right, let's do this one. Yeah, so z is not 1, then this plus this minus this doesn't have the real part. Okay, then you are all you have to do is plugging this one in here and there, right? So if you plug x plus iy, this one is 1 plus x plus iy over 1 minus x minus iy. Okay? Then I want to rationalize the denominator because I want to have only real number here so that I can make imaginary part and real part. Okay. So if you want to get rid of I, you are timesing. You are recognize this one is A, take away this one is B. So you need to times by A plus B, isn't it? Which means, right, so 1 minus x plus iy. And if you times by this number on top and bottom, you can cancel this I, okay? So I will show you the second step. This one and this one, okay? 1 minus x to the power of 2. Then this times this, so plus y squared as a denominator. And the numerator is gonna be, it's really hard to, how can I, so if you change this one in order of 1 plus iy plus x times by 1 plus iy minus x, and then you can use the same system, isn't it? This squared take away x squared, a minus b, a plus b. So 1 plus iy to the power of 2, and then take away x squared. Okay. Is there any questions so far? By the way, do people teach this level of math in college? Yes, we do teach this level. Yeah, in college. Yes. Right. Okay. Rationalize that. Yeah. Good. Right. Okay. So that so this part, shall we do 1 plus 2iy? Right, I will expand this one, okay? Plus, minus y to the power of 2, minus x2, over 1 minus 2x plus x squared plus y squared, okay? Then I want you to think of this one. X squared plus y squared as 1, which means negative x squared minus y squared equal negative 1, isn't it? Okay, which you can see here. So that means this part must be negative 1. Now what about here? This part is a positive 1, isn't it? Okay, well, to be honest, you don't have to do this one to find the answer. But anyway, 1 plus 1 is 2. 2 take away 2x is the bottom one. And the top one is 1 take away 1, which is cancelled. So that means 2y times by I is here, right? So this part must be real number. This part must be real number. So this part is one real number times by I. So that this part must be imaginary part. So this one is purely imaginary. This is the way you do it, okay? Right, so the last part is this question. I need a paper. Yep. Okay. Right. Okay, so this one is a proof that a quadratic equation, this one, will have two distinct real solutions for all value of k. So there are two, that's, where do you teach Yes. Yeah. I teach in New Zealand. Yeah. Anyway, yeah. Right. Okay. So the proof that the quadratic equation, this one, will have two distinct real solutions for all real value k. Okay. Put k equals 0. More like you need to show. This one is an excellence question, so that you can't really guess and check or anything like that. But what we are saying is that this is for all of whatever the value you put instead of k, you've got always two solutions for this one. Okay, but two solutions means that, so if the question is talking about the number of solutions, you always use this discriminant. Okay, discriminant as like when you're solving quadratic equation, this is a quadratic equation, isn't it? And then the discriminant is inside of this one. And then so let's say this is a discriminant. So if discriminant is bigger than 0, the quadratic graph has always two solutions. And if d equals 0, there's only one solution. And then if this one is smaller than 0, no solutions, isn't it? Okay. Which means we are doing the, all right, the question is here. Okay. Right, so to figure out d here, we need to have all the number on one side here, which means I need to take 7kx from here, so, and then 3k from here, which means my phone's not doing well today. X squared plus 3kx minus 7x plus k squared minus 3k equals 0. Okay, then if you focus on this part, okay, so this one is 3k minus 7x. This is b, isn't it? And then a is 1. And then c is k squared minus 3k as c. So discriminant as 3k minus 7 to the power of 2, and then minus 4 times by a, which is 1, times by k to the power of 2k. So if we can show this one as always positive number, and then that's our answer, isn't it? That's it, because you can prove this is a positive number, which means we have always two solutions for it. Okay. Yeah. All right. Is it okay for me to show the answer? Okay. So this is, you just expand for first step. 3 times 3 is 9. 3 times 7 is 21, times by 2 is 42k, plus 49, minus 4 times k squared, plus 12k. Okay, then you just calculate 5k squared, and then this, so minus 30k, plus 49. Okay, so there are two approaches you can think of to figure out this one is always positive number. One is a perfect squared, and then one is you're using another quadratic formula, discriminant. Then I will show both way. So I need a paper. Yep. Right, I need a both way. We'll use this paper. Okay, good. Right. Is that okay? I mean, you can skip. Oh, yeah. Okay. Right. So this one, if you do you know what perfect square form is? I changed this form into this form. I take step by step. Like this. So if you change this form into perfect square, which means you can show k minus 3 to the power of 2 as always bigger than 0, isn't it? Which means 5k minus 3 to the power of 2 plus 4 as always bigger than this as bigger than 0, which means bigger than 4, which means obviously bigger than 0, so there are always two solutions. Okay, this perfect square form is really useful when you're trying to figure out the turning point of the quadratic graph, because this is a vertex form for quadratic equation, isn't it? Right? In quadratic graph, parabola. Okay, but there are another approach that I can think of, so that I will share with you. Okay, that is gonna be the last one. Okay, so this one is we want to figure out whether this one is always positive or not. Then if I write d equal 5k squared minus 30k plus 49, that means I can draw a graph for this one. I draw k instead of x axis, and then d instead of y axis. Okay, and then if the graph is like this, that means that d value of d is always positive, isn't it? Which means if you use the discriminant of this expression as smaller than 0, that means there is no solutions, which is always positive, is a positive numbers. Does it make sense? And then yeah, you need to mention that this one is a positive graph. If this is a negative graph, this is totally opposite. But because the coefficient of k squared is positive, this graph is going to be positive. And then if discriminant of, right, let's say dk, let's say this one dk as this squared, so it's 900 minus 4 times by 5 times by 49. This one is a 900 take away 4 times 5 is 20, so the 2 times by, so that 50 times by 2 take away 2, So the 100 take away is 980, isn't it? This is negative 80, which is smaller than 0, which means there is no solutions, which means and it is positive graph. So so D is always positive, like that. No roots for decay, so that D is always positive. Yeah. I don't know why I'm watching this. I left school 20 years ago, but thank you anyway. No problem. I like it. Yeah. What does 30K signify? Signify 30K. 30K. It came from this one. It's a negative 42 plus 12, and then 30K. And then this one, I recognize 30 as B, 5 is A, and then 49 as C. And then I did a B squared minus 4AC for here. Hope this might make sense. Yeah. Right. So there are no roots for decay, so that D is always positive. Only if this graph is positive, which you can identify. So let's say paper. So if y equal ax squared plus bx plus c, if A is positive, the graph is always positive. Okay, and then if A is negative, graph is always negative this way. So which means if D is smaller than 0, which means it's not crossing the x axis, okay? Which means if the graph is positive and then it's not crossing, which means the value of y here is always positive. And the opposite, the value of y is always negative. Okay. Sense can, yeah, good. Is it, Jonathan, does it make sense? Yeah, how does it affect that graph? That affects the graph. You mean the value B is a little bit interested that how open the graph is. And then value C is basically y coordinate, isn't it? So shifting this one up and then down. And then B is moving around, so that if the y coordinate is C is here, and then y equal ax plus bx plus c, and then if you change B, the first one was like this, and if you change the B value, this graph is going this one, and then changing this one is going this way, and then this way, like that. So that B decide the location of this one, and then C is deciding the up and down here. So the for B is more like a shifting right and left, but more like moving this movement. And then A is obviously open this way or open this way, or if the A is smaller, it becomes wider, and then like that. Oh yeah, good. Makes sense. Good. Right. Okay. So this is all question I wanted to cover for today. Is there any questions that you want me to talk about? Good, and that's great. Right. So there are how many minutes? Yeah. I will stay on a little bit more longer so that I can keep talking about talking about math for 2 hours. Spending 2 hours on live is my goal for today as well. So that that's probably So I've got another 5 minutes to talk to you guys. But if you have any questions, I can answer if I can answer. Yeah. Or it's all right. Any? I wonder. New message. Do you have YouTube? Yes, I have YouTube channel. YouTube. I'm trying to take YouTube a little bit more seriously from now because I realize that my student can't really access TikTok at school because we are using school Wi-Fi. So that if you're searching the mathematics sensei on YouTube, mathematics sensei, I'm sure you can see the same logo of mine on YouTube. So it would be great if you can follow my YouTube channel so that you that would be great. Yeah. Hello. Yes, that's good. Well, it's really high level, but still 10 people are watching it. That's great. And then quite a few. Where else are you also teaching? I'm actually from Japan, so I used to be a math teacher in Japan as well. Yeah. Then I used to teach at the Japanese school inside of New Zealand as well. Yeah. So I'm not super good at statistics, but I can teach Cambridge math or IB math or that sort of stuff as well. Yeah. Yes. Yeah. I'm not too sure I'm allowed to tell you about what school I'm teaching and that sort of stuff because it affects on my school. Yeah, so that I try not to talk about my specific I can talk about my school because my school is great. Even though that online there are quite a few people are talking about negative stuff, but I quite like my school, and then I enjoy teaching there. Kids are really nice, and yeah. So I'm only on pre-calculus, hoping to reach calculus level 3 someday. Oh yeah, someday next year, because you're doing pre-calculus, right? What that means, level 3 calculus next year. So if you're taking a challenge, I really strongly recommend you to follow me on TikTok and YouTube. Yeah, that's great. Yeah. Yep. So is it yeah, 2 more minutes and then I'm going, but yeah. Is there any questions? Yeah. Right. If you see this one, so our school is using education perfect here, so that I've got the pen from it. But yeah, if you're in New Zealand, you know what it is. I probably, yeah. I've got a Math X pen as well. Yeah, but all right. Yeah. So if you can follow my YouTube channel as well, that would be great. And if you can, obviously, if you can follow my TikTok account, it would be great. And sometimes I upload on Instagram as well. Not much, but I prefer creating the videos and teaching live streaming, teaching math on live streaming and that sort of stuff. Okay. I was asking school or college level math is this. This is a level 3 math. So that year 13, the last year of New Zealand school. So that, yeah, and then they are taking the exam in 1 month. So that's why 1 month, 1.5 months. That's why I organized, yeah, to talk about this one. But I think I made a mistake. I gave the wrong link to my level 3 students. So that I'm not too sure how many students from my level 3 calculus class showed up for my, yeah, TikTok ban in India. That's sad. Okay, so yeah, that's why you are on YouTube, isn't it? Okay. But yeah, that's probably it from me. I don't know, I can type like here, and then like here as well. I can like to myself. Anyway, right, okay, thank you very much. Then I'm going basically go to sleep now. Okay, thank you for coming, and then yeah, thank you for coming, and see you next time. Cheers.